Thank you. Wow, it's so unusual to hear myself on the speakers. Believe it or not, that is my first public speech in English and on a such big audience. I'm really excited about it, really thrilled, a bit nervous. Yeah, but I think we're gonna have make a fun of it. So, just before I begin, I'm just asking: does anybody have Rotten Tomatoes with a cell? I'm just asking. So let us begin with WWDC. We all put high hopes on a WWDC each year. It is like an IT Christmas for those who loves Macs and Apple. It motivates us to save money for new devices. And each year we have high expectation and rumors about it. And sometime Apple, along with loud and big announcements and releases, introduced a very promising technology that I'd like to share with you. But before, let me introduce myself. My name is Serhi. I'm that very person who awaits a WWDC, sometimes even more than Christmas. And I'm a software engineer at MacPo in a setup team. I'm very enthusiastic, and it makes me really proud to work with hundreds of people whose purpose is to make technologies help people. And I'm really grateful for organizers, for you guys, to be able to complete this mission here, right on this stage. And today, we're going to see how to put this inside of this. One Mac inside of other Mac. And the technology I'm going to talk about today is virtualization, that you probably might have seen before in the announcement. Yeah, but anyway, some of you probably are using a dedicated software for virtualization. Well, does anybody? Oh, unexpected. So yeah, there is a dedicated software already, but today I'm going to show you another way to do it from a developer's perspective. And it's never been easier to run a virtual machine. And the approach I'm going to share with you today is efficient, and it is best of all, it's free. Like any other operating system, everything starts from the roots, which in our case is the hardware of your Mac. And at the top of hardware, there is a macOS kernel. And if we add something to this, which is eventually the virtualization framework, we will be able to create and use virtual machines running macOS and even Linux. So this is going to be our topic for today. And here's the full agenda that I'm going to share. So first, I'll tell you about the requirements and limitation of this technology. Then we're going to see the basics of the virtualization framework. Right after, we'll continue our way and see how to create a macOS virtual machine and a Linux one. And finally, I'm going to show you some great examples of products that already benefit from using this framework and give you a short summary. So, sounds like a plan, and let's do that. So the requirements, they are slightly different for macOS and Linux machines. Let's first look at macOS requirements. So the minimum macOS version supported by virtualization framework is macOS 12, as known as Monterey. It relates to both host and virtual machine, and later I'll explain you why it is that. Another limit is that for macOS virtual machines, they are supported on Apple Silicon Macs. The thing is that these virtual machines are very efficient. They communicate directly with a macOS kernel, and this requires special technology that is available on Apple Silicon Macs. And also, you'll need an Xcode if you write code by your own. And also, if you need to run a virtual machine with a version newer than your host machine. And finally, you'll need some knowledge of Swift, if again you'd like to build everything by your own. As for Linux, we have a slightly wider limits. First of all, Linux virtual machines require macOS 11 and higher, and also supported on Intel Macs. You'll still need Xcode and some knowledge of Swift if you like to run everything manually and by your own. So let's take a closer look on how to work with virtualization framework. In fact, it has pretty straightforward API, and there are only three main kind of objects that you're gonna work with. First is configuration of your virtual machine. The next one is a virtual machine representation itself, which you can start, stop, pause, restore, etc., just to control the state of your machine. And the last one, a view to embed your virtual machine in, to be able to interact with it. And there are three main stages to have a virtual machine running from scratch. You always start with creating a configuration. For me, this is the most funny part, because the process is actually similar to what you do on Apple Store website while configuring your new Mac. And you set the number of cores, the memory size, the devices available, the graphics, etc. Next. Then you create a virtual machine representation and pass a newly created configuration to it. This step also includes the process of installation of the newly created operating system. And finally, you display and start your virtual machine. So just 3 steps. And does anybody want to see how it looks in code? I'm glad, because I've prepared slides, and they actually coming next, so we couldn't have skipped them anyway. So we're glad that someone is waiting for them. But don't worry, as I mentioned, we'll be using Swift language, which is quite readable and straightforward. And I just want to show you an example of what's happened inside, but you probably don't need to remember everything, because at the end, I'm going to show you a beautiful paysage. And I'm going to show you great examples of tools that might help you without even coding a line of code. So as I said, we start with a new virtual machine configuration, and currently it's like a blank page that we can turn into whatever we'd like. So here we set a hardware characteristics of the future Mac, the CPU count, memory size, storage devices, pointing devices. And here we're moving to what makes a macOS a macOS. And we're going to create a platform object, which is, in this case, represented by Mac platform configuration class. It still needs to know some hardware properties of a future Mac. And it can be Mac Mini or MacBook Pro. And we set it right here with a Mac hardware model object. Of course, we need some storage, so we added using auxiliary storage object and pass there a URL to a file that we act like a storage. And a machine identifier to distinguish this virtual machine from others. It is a unique number that identifies the machine, and when our platform is set, we're ready to pass it to the configuration. So the basic preparation is ready. Now we need to think how to boot it. Or we don't need to, because there is a built-in macOS bootloader embedded in the virtualization framework. And I just set a bootloader property with a VZ macOS bootloader object. And like any macOS, this one also needs to be installed before the first usage. And for that, we need a restore image. We can download it from the Apple website or use a dedicated property also available in virtualization framework, which is latest supported. And I also think that you can also use restore images created by your own. I don't see any limitation on that. And each restore image has a property that represents the most featureful configuration. And we usually use it instead. We use it to set the physical properties of the new Mac instead of setting the constants to these fields. And we're close to finishing up. So let's create a virtual machine object with our configuration, which is now ready for installation. To begin installation, we're going to use the built-in macOS installer. It might take some time, and when it's finished, the virtual machine can be finally started. So this is how you create and set up the virtual machine. Of course, there are many more hidden gems and features that you can customize. Let me just show you some of the most interesting ones. Yeah. So, as I told before, this virtual machine are very performant, and they can even support GPU acceleration like this. And to be honest, I don't find a real-world use case where you're gonna use complex 3D objects or model in a virtual machine, but yeah, you can still do that. But GPU acceleration in general improves the animations, make them much smoother and performant, and here's how to add this feature. The thing I missed previously is the graphics. We need to set up a virtual display, and here I use a built-in graphic device that exposes the GPU capacities to future Mac. It's supposed metal, so it can give you great graphics performance. However, it is currently only works for macOS virtual machines. Each Mac laptop has a trackpad, and I guess we all gotten used to it, but it isn't a regular pointing device. It is something more. It supports gestures, many gestures, and by default, it isn't available in a virtual machines. Fortunately, you can get all these gestures working inside a virtual machine. All you need to do is to add a trackpad pointing device, and this is that easy. So here, at this time, you're gonna have trackpad support. Here's an interesting one and useful. File sharing between the host system and the virtual one. Fortunately, this is possible and makes a great use of virtual machines. And this feature was firstly introduced with a macOS Ventura via the virtual file system. Sorry for that. I should have make a bigger sleep time for my Mac. So here, as you add a shared directory, and you can choose which folders to share with the virtual machine. It can be one folder or several folders, and all changes you made in these folders will be displayed immediately in both host and the virtual machine. And I haven't yet discussed how to actually display a virtual machine. Well, we just use virtual machine view, the third component I've been talking about before, and it has a property virtual machine, which is, as you may guess, accept virtual machine, and it has a support in AppKit or SwiftUI. And the recent feature that was added there is an ability to dynamically change the screen size of the virtual machine by just resizing the window, and it automatically changes the screen size of a virtual system that lives inside this window. Another important thing is saving your progress while you're working. And this year, Apple also introduced saving and restoring the state of your virtual machine. And it is just a single line of code for both tasks. However, this should be done while the virtual machine isn't running. And due to security reasons, this file could be created and used only on your host macOS system. And finally, network storage support was also introduced just this year. This is how you add it. And note that you need to configure an NBD server, which is Network Block Device Server, again, for security reasons. And Linux. Whew. I can congratulate you that the most difficult part is behind. And setting up a Linux machine is pretty much common with a Mac. However, it has a few differences. So usually you install Linux from a USB flash drive with an image burned on it. So the process is pretty much similar here. So we take a disk image previously downloaded on our Mac, create a virtual USB device, and add it as an additional storage. To boot from it, we use a EFI bootloader, and it's also available out of the box in virtualization framework. And thanks to Discovery technology, it scans all the storages and detects which one it can boot from. And it detects our USB device and boots from it, and starts the installer from the virtual USB drive. Another thing is graphic. For graphic device in Linux, we use Virtual GPU 2D. And this is it. And we've seen much code so far, probably more than you expected before coming to this conference. And now I'm going to show you some great tools that harness the power of this great technology. And the first one is a virtual body. It is an open source tool created by Julien Rambo. I hope I pronounced the name correctly. I'm sorry if I'm not. It has a great UI where you can set pretty everything I've been talking about before. So here's how it looks like. You can also download the macOS Restore images directly into the app, install them, and create as many virtual machines as you'd like. Linux also available here, of course, and according to the product GitHub page, the ability to download a Linux disk images directly in the app will be coming later. Another great product is a UTM app. This one uses a virtualization framework along with hypervisor framework, which is baked in the virtualization one, but is more low level. And this one is available to run ARM operating systems, but also it provides an easy to use from a QEMU emulation software. QEMU can emulate other processor architectures, including x86, like this beautiful Windows XP, or PowerPC. Like all emulation, this comes with a performance penalty, but it is a great way to run an operating systems, an old one on a modern Macs. And by the way, we have a retro Mac on our MacPost stand here, which actually runs a macOS 9. So for this one, you won't need a virtualization, so you feel free to come and play with it to see the true OS 9 laptop. My colleagues would be happy to tell you more about it. So, well, that's pretty it. So I'm going to tell you some conclusions. So virtualization framework is fun and easy to use, and indeed it can be a powerful tool and quite beneficial as well. It has become one of the coolest, as I think, the power user feature on macOS since the Apple Silicon era. And virtualization lets you run multiple operating systems on Mac simultaneously, which was a feature previously available only by a paid software. And this is useful for anyone who wants to run Linux on the top of the macOS system to test on applications on a different environments, or review the latest macOS beta without risking their primary host system. However, it does have some limitation that you need to know about. So the graphics acceleration is only available so far for macOS virtual machines. And on macOS virtual machines, if you try to sign in into an iCloud account, it will tell you an error. And some features that requires direct communication with the hardware tools like Wi-Fi or Bluetooth. This is AirDrop or some continuity features. Doesn't work so far as well, but probably in the future they will. We'll see. And finally, you can't virtualize any version of macOS older than 12, which is Monterey. Big Sur restore image will produce an error, and macOS Catalina and earlier doesn't support Apple Silicon at all, so that's why it's not possible to run them using the virtualization framework. And for this task, you still need a dedicated software. So if you have any questions, feel free to ask, or you can just scan the clip code to get in touch with me later, and this is how it works. Actually, I created these applications a few days before the conference, and I was lucky to get an approval from Apple on an App Store review. So you can find my contact there, and we can get in touch, and then I will respond your question with a great pleasure. So thank you, everyone, and feel free to ask some questions, or just have fun next.
All right, great. So we have a couple of minutes. Is there any questions? Oh, you're so post-lunch, everyone.
That's okay.
Well, you'll be here all week, won't you?
Yeah, absolutely.
Yeah. So you can find him at... Oh, we have Kat has a question.
Okay, so when you're using this virtualization software, or this facet, does it still base the image off? So if I have an MDM, right, if I'm using my work laptop and I want to create a virtual machine, will it still be registered when I create this virtualized image as my company's?
Sorry, and what the question, should it be registered, could it be enrolled into the MDM, right?
So I don't want it to be enrolled in the MDM. I want to be able to have
it is like another operating system running in parallel with the host one, so it doesn't translate the commands and signal to the kernel through the operating system, but they use them in parallel, and that's why they are so performant so far. So it isn't related with the host system at all.
Perfect, thanks.
Question over there?
Over here. There you go.
Would you recommend using this framework for malware analysis?
I think it's a good
Can you isolate
use
the
case.
network, or can you restrict Word.io to not connect out?
I think this is a good case for testing malware. I would rather not to have any shared directories when I start, but in another case, it's gonna be a great use of it.
Cool. Thank you very much.
Thank you too. It was a pleasure to speak to you.